Okay, so we have a function here, and they're only telling us a little bit about it. They tell us that its slope is x over 2. Now, that means the slope is changing all the time, and it means that as you're graphing this thing, when x is negative, the slope would be negative, and when x is positive, the slope would be positive, and when x is 0, the slope would be 0. So this thing is looking quite a bit like a parabola, and indeed it's going to be. We'll prove that in a minute by doing the antiderivative. But we can see it coming just from thinking a little bit about what the slope means. If our slope is x over 2, we know that the slope is the first derivative of a function. So we have a function whose first derivative is x over 2, or I'm going to write it as 1 half x. And I'm going to take that dx and scooch it over to the right because I like this format better. If we integrate this, on the left side we just get y. And here from the power rule we get our power goes up by 1, we divide by the new power, and we get 1/4 x squared, and a plus c pops out. What this is saying is, if your slope is x over 2, then your function must be 1/4 x squared. The trouble is, the math doesn't know if we're talking about a parabola that looks like this, or the exact same parabola, only 5 feet lower down, or maybe 1.5 feet higher up, or maybe way down here. The slope doesn't tell us anything about the vertical position, and so for the moment we've got an infinite set of possible solutions. This is what we call a family of curves. It's a set of curves that are identical except for one of their parameters, which isn't set, or it could be a bunch of different values. And so right now our solution is this family of curves, and we'd like to nail it down to one specific curve by finding a specific value for c. And we can do that because they've given us an extra point. They say, oh, by the way, we mean the one that has a y-intercept of 3. Hey, that's this one. It's the one where when x is 0, y is 3. You can see on the graph how that immediately narrows us down to one specific parabola. And over in the math, that means when x is 0, y is 3. Let's see what that does to our equation. Y is 3. X is 0. C, guess what? You can't hide anymore. 0 squared is 0 times 1/4 is 0. 3 equals c. We got the value just like that. So our function is y equals, we knew this part already, 1/4 x squared, plus, and now we don't have to say c anymore, we know what its value is. So, ta-da, there is our original function. If you differentiate it, you'll find its derivative is 1/2 x, or x by 2, just like they said. If you find its y-intercept, well, you can tell at a glance that that's going to be 3. So